Another reason for the higher local diversity of domesticated plants and animals in Eurasia than in the Americas is that Eurasia's main axis is east-west, whereas the main axis of the Americas is north-south. Eurasia's east-west axis meant that species domesticated in one part of Eurasia could easily spread thousands of miles at the same latitude, encountering the same day length and climate to which they were already adapted. As a result, chickens and citrus fruit domesticated in Southeast Asia quickly spread westward to Europe. Horses domesticated in the Ukraine quickly spread eastward to China, and the sheep, goats, cattle, wheat, and barley of the Fertile Crescent quickly spread both west and east. In contrast, the north-south axis of the Americas meant that species domesticated in one area couldn't spread far without encountering day lengths and climates to which they were not adapted. As a result, the turkey never spread from its site of domestication in Mexico to the Andes. Llamas and alpacas never spread from the Andes to Mexico, so that the Indian civilizations of Central and North America remained entirely without pack animals. And it took thousands of years for the corn that evolved in Mexico's climate to become modified into a corn adapted to the short growing season and seasonally changing day length of North America. Eurasia's domesticated plants and animals were important for several other reasons besides letting Europeans develop nasty germs. Domesticated plants and animals yield far more calories per acre than do wild habitats, in which most species are inedible to humans. As a result, population densities of farmers and herders are typically 10 to 100 times greater than those of hunter-gatherers. That fact alone explains why farmers and herders everywhere in the world have been able to push hunter-gatherers out of land suitable for farming and herding. Domestic animals revolutionized land transport. They also revolutionized agriculture, by letting one farmer plow and manure much more land than the farmer could till and manure by the farmer's own efforts. Also, hunter-gatherer societies tend to be egalitarian and to have no political organization beyond the level of the banded tribe. Whereas the food surpluses and storage made possible by agriculture permitted the development of stratified, politically centralized societies with governing elites. Those food surpluses also accelerated the development of technology, by supporting craftspeople who didn't raise their own food and who could instead devote themselves to developing metallurgy, writing, swords, and guns. Thus, we began by identifying a series of proximate explanations divided by guns, germs, and so on divided by for the conquest of the Americas by Europeans. Those proximate factors seem to me ultimately traceable in large part to the Old World's greater number of domesticated plants, much greater number of domesticated animals, and east-west axis. The chain of causation is most direct in explaining the Old World's advantages of horses and nasty germs. But domesticated plants and animals also led more indirectly to Eurasia's advantage in guns, swords, ocean-going ships, political organization, and writing, all of which were products of the large, dense, sedentary, stratified societies and made possible by agriculture. Let's next examine whether this scheme, derived from the collision of Europeans with Native Americans, helps us understand the broadest pattern of African history, which I'll summarize in 5 minutes. I'll concentrate on the history of sub-Saharan Africa, because it was much more isolated from Eurasia by distance and climate than was North Africa, whose history is closely linked to Eurasia's history. Here we go again. Just as we asked why Cortes invaded Mexico before Montezuma could invade Europe, we can similarly ask why Europeans colonized sub-Saharan Africa before sub-Saharans could colonize Europe. The proximate factors were the same familiar ones of guns, steel, ocean-going ships, political organization, and writing. But again, we could ask why guns and ships and so on ended up being developed in Europe rather than in sub-Saharan Africa. To the student of human evolution, that question is particularly puzzling. because humans have been evolving for millions of years longer in Africa than in Europe. And even anatomically modern Homo sapiens may have reached Europe from Africa only within the last 50,000 years. If time were a critical factor in the development of human societies, Africa should have enjoyed an enormous head start and advantage over Europe. Again, that outcome largely reflects biogeographic differences in the availability of domesticable wild animal and plant species. Taking first domestic animals. It's striking that the sole animal domesticated within sub-Saharan Africa was, you guess, a bird, the guinea fowl. All of Africa's mammalian domesticates divided by cattle, sheep, goats, horses, even dogs divided by entered sub-Saharan Africa from the north, from Eurasia and North Africa. At first that sounds astonishing, since we now think of Africa as the continent of big wild mammals. In fact, none of those famous big wild mammal species of Africa proved domesticable. They were all disqualified by one or another problem such as unsuitable social organization, intractable behavior, slow growth rate, and so on. Just think what the course of world history might have been like if Africa's rhinos and hippos had lent themselves to domestication. If that had been possible, African cavalry mounted on rhinos or hippos would have made mincemeat of European cavalry mounted on horses. But it couldn't happen. Instead, as I mentioned, the livestock adopted in Africa were Eurasian species that came in from the north. Africa's long axis, like that of the Americas, is north-south rather than east-west. Those Eurasian domestic mammals spread southward very slowly in Africa, because they had to adapt to different climate zones and different animal diseases. The difficulties posed by a north-south axis to the spread of domesticated species are even more striking for African crops than they are for livestock. Remember that the food staples of ancient Egypt were fertile crescent and Mediterranean crops like wheat and barley, which require winter rains and seasonal variation in day length for their germination. Those crops couldn't spread south in Africa beyond Ethiopia, beyond which the rains come in the summer and there's little or no seasonal variation in day length. Instead, the development of agriculture in the sub-Sahara had to await the domestication of native African plant species like sorghum and millet, adapted to Central Africa's summer rains and relatively constant day length. Ironically, those crops of Central Africa were for the same reason then unable to spread south to the Mediterranean zone of South Africa, where once again winter rains and big seasonal variations in day length prevailed. The southward advance of native African farmers with Central African crops halted in Natal, beyond which Central African crops couldn't grow, divided by with enormous consequences for the recent history of South Africa. In short, a north-south axis, and a paucity of wild plant and animal species suitable for domestication, were decisive in African history, just as they were in Native American history. Although native Africans domesticated some plants in the Sahel and in Ethiopia and in tropical West Africa, they acquired valuable domestic animals only later, from the north. The resulting advantages of Europeans in guns, ships, political organization, and writing permitted Europeans to colonize Africa, rather than Africans to colonize Europe. Let's now conclude our whirlwind tour around the globe by devoting 5 minutes to the last continent, Australia. Here we go again, for the last time. In modern times, Australia was the sole continent still inhabited only by hunter-gatherers. That makes Australia a critical test of any theory about continental differences in the evolution of human societies. Native Australia had no farmers or herders, no writing, no metal tools, and no political organization beyond the level of the tribe or band. Those, of course, are the reasons why European guns and germs destroyed Aboriginal Australian society. But why had all native Australians remained hunter-gatherers? There are 3 obvious reasons. First, Even to this day, no native Australian animal species and only one plant species, the macadamia nut, have proved suitable for domestication. There still are no domestic kangaroos. Second, Australia is the smallest continent, and most of it can support only small human populations because of low rainfall and productivity. Hence the total number of Australian hunter-gatherers was only about 300,000. Finally, Australia is the most isolated continent. The sole outside contacts of Aboriginal Australians were tenuous overwater contacts with New Guineans and Indonesians. To get an idea of the significance of the small population size in isolation for the pace of development in Australia, consider the Australian island of Tasmania, which had the most extraordinary human society in the modern world. Tasmania is just an island of modest size, but it was the most extreme outpost of the most extreme continent. And it illuminates a big issue in the evolution of all human societies. Tasmania lies 130 miles southeast of Australia. When it was first visited by Europeans in 1642, Tasmania was occupied by 4,000 hunter-gatherers related to mainland Australians, but with the simplest technology of any recent people on Earth. Unlike mainland Aboriginal Australians, Tasmanians couldn't start a fire, they had no boomerangs, spear throwers, or shields, they had no bone tools, no specialized stone tools, and no compound tools like an axe head mounted on a handle. They couldn't cut down a tree or hollow out a canoe, they lacked sewing to make own clothing, despite Tasmania's cold winter climate with snow, and, incredibly, though they lived mostly on the sea coast, the Tasmanians didn't catch or eat fish. How did those enormous gaps in Tasmanian material culture arise? The answer stems from the fact that Tasmania used to be joined to the southern Australian mainland at Pleistocene times of low sea level, until that land bridge was severed by rising sea level 10,000 years ago. People walked out to Tasmania tens of thousands of years ago, when it was still part of Australia. Once that land bridge was severed, though, there was absolutely no further contact of Tasmanians with mainland Australians or with any other people on Earth until European arrival in 1642. Because both Tasmanians and mainland Australians lacked watercraft capable of crossing those 130-mile straits between Tasmania and Australia. Tasmanian history is thus a study of human isolation unprecedented except in science fiction, divided by, namely, complete isolation from other humans for 10,000 years. Tasmania had the smallest and most isolated human population in the world. If population size and isolation have any effect on accumulation of inventions, we should expect to see that effect in Tasmania. If all those technologies that I mentioned, absent from Tasmania but present on the opposite Australian mainland, were invented by Australians within the last 10,000 years, we can surely conclude at least that Tasmania's tiny population didn't invent them independently. Astonishingly, the archaeological record demonstrates something further. Tasmanians actually abandoned some technologies that they brought with them from Australia and that persisted on the Australian mainland. For example, bone tools and the practice of fishing were both present in Tasmania at the time that the land bridge was severed, and both disappeared from Tasmania by around 1500 BC. That represents the loss of valuable technologies. A fish could have been smoked to provide a winter food supply, and bone needles could have been used to sew warm clothes. What sense can we make of these cultural losses? The only interpretation that makes sense to me goes as follows. First, technology has to be invented or adopted. Human societies vary in lots of independent factors affecting their openness to innovation. Hence, the higher the human population and the more societies there are on an island or continent, the greater the chance of any given invention being conceived and adopted somewhere there. Second, for all human societies except those of totally isolated Tasmania, Most technological innovations diffuse in from the outside, instead of being invented locally. So one expects the evolution of technology to proceed most rapidly in societies most closely connected with outside societies. Finally, technology not only has to be adopted, it also has to be maintained. All human societies go through fads in which they temporarily either adopt practices of little use or else abandon practices of considerable use. Whenever such economically senseless taboos arise in an area with many competing human societies, only some societies will adopt the taboo at a given time. Other societies will retain the useful practice, and will either outcompete the societies that lost it, or else will be there as a model for the societies with the taboos to repent their error and reacquire the practice. If Tasmanians had remained in contact with mainland Australians, they could have rediscovered the value in techniques of fishing and making bone tools that they had lost. But that couldn't happen in the complete isolation of Tasmania, where cultural losses became irreversible. In short, the message of the differences between Tasmanian and mainland Australian societies seems to be the following. All other things being equal, the rate of human invention is faster, and the rate of cultural loss is slower, in areas occupied by many competing societies with many individuals and in contact with societies elsewhere. If this interpretation is correct, then it's likely to be of much broader significance. It probably provides part of the explanation why native Australians, on the world's smallest and most isolated continent, remained Stone Age hunter-gatherers, while people of other continents were adopting agriculture and metal. It's also likely to contribute to the differences that I already discussed between the farmers of sub-Saharan Africa, the farmers of the much larger Americas, and the farmers of the still larger Eurasia. Naturally, there are many important factors in world history that I haven't had time to discuss in 40 minutes, and that I do discuss in my book. For example, I've said little or nothing about the distribution of domesticable plants, 3 chapters. About the precise way in which complex political institutions and the development of writing and technology and organized religion depend on agriculture and herding. About the fascinating reasons for the differences within Eurasia between China, India, the Near East, and Europe, and about the effects of individuals and of cultural differences unrelated to the environment on history. But it's now time to summarize the overall meaning of this whirlwind tour through human history, with its unequally distributed guns and germs. The broadest pattern of history divided by, namely, the differences between human societies on different continents divided by, seems to me to be attributable to differences among continental environments, and not to biological differences among peoples themselves. In particular, the availability of wild plant and animal species suitable for domestication, and the ease with which those species could spread without encountering unsuitable climates, contributed decisively to the varying rates of rise of agriculture and herding, which in turn contributed decisively to the rise of human population numbers, population densities, and food surpluses, which in turn contributed decisively to the development of epidemic infectious diseases, writing, technology, and political organization. In addition, the histories of Tasmania and Australia warn us that the differing areas and isolations of the continents, by determining the number of competing societies, may have been another important factor in human development. As a biologist practicing laboratory experimental science, I'm aware that some scientists may be inclined to dismiss these historical interpretations as unprovable speculation, because they're not founded on replicated laboratory experiments. The same objection can be raised against any of the historical sciences, including astronomy, evolutionary biology, geology, and paleontology. The objection can of course be raised against the whole field of history, and most of the other social sciences. That's the reason why we're uncomfortable about considering history as a science. It's classified as a social science, which is considered not quite scientific. But remember that the word science isn't derived from the Latin word for replicated laboratory experiment, but instead from the Latin word scientia, for knowledge. In science, we seek knowledge by whatever methodologies are available and appropriate. There are many fields that no one hesitates to consider sciences, even though replicated laboratory experiments in those fields would be immoral, illegal, or impossible. We can't manipulate some stars while maintaining other stars as controls. We can't start and stop ice ages, and we can't experiment with designing and evolving dinosaurs. Nevertheless, we can still gain considerable insight into these historical fields by other means. Then we should surely be able to understand human history. Because introspection and preserved writings give us far more insight into the ways of past humans than we have into the ways of past dinosaurs. For that reason, I'm optimistic that we can eventually arrive at convincing explanations for these broadest patterns of human history.